an almost limitless supply of clean energy has been brought one step closer to reality after a team in the US set a new record for nuclear fusion by smashing the previous record for plasma pressure. One of the core components of the fusion process, engineers and scientists have nudged the process further along the road towards a viable source of energy production. While using nuclear fusion to power homes and businesses may still be some way off, the work proves that the burning of star-like fuel can be achieved and contained using the current approach. Nuclear fusion is being looked to as a potentially limitless source of clean energy, created by the same core processes inside the Sun. Using intense heat, magnetic fields and pressure, the nuclei of lighter elements are fused together to create heavier elements, releasing energy in the process. By containing the star-like process in specially designed reactors, engineers can fuse hydrogen atoms together to produce helium, harnessing the clean energy produced and potentially cutting dependency on fossil fuels. In order for the reaction to take place, the superheated gas in a plasma state is subjected to pressure, which essentially squeezes the atoms together and forces them to react. The work, carried out at the MIT Plasma Science and Fusion Center in Cambridge, Massachusetts, pushed the pressures involved up to 2 atmospheres, breaking the previous record by 15%. They achieved the pressures using MIT's custom Allocator CMOS tokamak reactor, which uses intense magnetic fields to contain the reaction within a fixed volume, with the pressure maintained at 2.05 atmospheres of pressure, equivalent to 10 meters below the surface of the ocean. The temperature inside the reactor reached more than 35 million degrees Celsius, more than double the temperatures achieved in the Sun's core. According to MIT News, the conditions inside the reactor generate hundreds of trillions of fusion reactions every second inside a single cubic meter. This is a remarkable achievement, Dale Mead, former deputy director at the Princeton Plasma Physics Laboratory, not directly involved in the experiments, told MIT News. The record plasma pressure validates the high magnetic field approach as an attractive path to practical fusion energy. The findings were presented today at the International Atomic Energy Agency Fusion Energy Conference in Kyoto, Japan. Aside from the pressures involved, which are seen as a significant technical challenge, the main hurdle for fusion reactors is the energy they take to get the reactions going. Superheating gases to reach plasma states, producing the pressures to boost the reactions and generating the intense magnetic fields to contain it all requires millions of watts of power, far more than the reactions themselves currently produce. In order for the process to be economically viable, the output has to be vastly increased beyond the input. Other groups outside the US are looking to push the energy-producing capacity of the technology even further, such as the ITER reactor currently under construction in France. It will be the largest tokamak-style reactor ever built and will be 800 times the volume of MIT's reactor. Engineers on the project hope to achieve pressures of 2.6 atmospheres of pressure when the reactor is fully operational and generate temperatures of 150 million degrees Celsius.